Hey math kids, today we're going to learn how to use the box method of factoring a quadratic. So in the previous method, the t-factoring method, we were thinking of quadratics in standard form, which look like this. And in that previous method, the a had to be a 1. Now this one's quadratic. We know it's quadratic because it has x squared as the highest power of x, but it wouldn't work for the previous method because we have a 15 out in front. Now this method allows us to use quadratics that have a different number out in front. So the first step that we're going to do is we're going to multiply the a number and the c number. So the number in front of x squared and the number that's by itself. So we multiply those together, we end up with negative 30, and then we're going to do the same thing. We're going to t-factor that portion. So we start with 1 and go to 30, 2, go to 15, 3 times 10, 4 doesn't multiply to make 30, so we move on to 5 and get 6. There's no whole numbers in between 5 and 6, and so that's how we know we have everything that we can. Now, just like in the t-factoring method, we want them to add up to the b number. So we have a positive 7. There's no way to do these ones, no way to do these ones, or these ones. However, if we do a negative 3 and a positive 10, that works. Now we want to double check. If we multiply those together, do we get negative 30? We do, so we know these are the right things. Now, in the previous method, we could just write the answer from this step. Unfortunately, we can't do that. So instead, I'm going to draw a box. This is why it's called box method. Now, this part's a little tricky, but what we're going to do is we're going to take the first term and the last term and just write them in these two boxes. And now what we're doing right here is we're going to split this 7x into two terms. It's like the opposite of combining like terms. What we're actually doing is we're going backwards through simplification. And so if you remember back when we were multiplying polynomials together, back last, or actually in the first unit in this class, often we would get things that had to be added together and combined. And we're just going the opposite. So we're going to use this to help guide us, and we're going to do a negative 3x and a positive 10x. Now if we added both of those together, it would give us 7x. And so this really is just a different representation of what we have up here. Now the next step that we want to do, we want to factor out by rows and by columns. So if we're just looking at this row, 15 and 10 are both divisible by 5. You want to choose the largest number that they're both divisible by. This has an x squared, which we think of as having two x's, and then this has a single x, and so we can only take out one x. Now these are both negative, so I'm going to take out a negative 1. And this has an x and this doesn't, so that's all I can take out. Now we're going to look at the column, and we have 15 and 3, so you can take out a 3, and then there's 1x we can take out. And then this is 10 and 2, so we can take out a 2. Okay, now there's a lot of different shortcuts with signs and all that stuff, but a lot of kids forget how to use that. So what I suggest is this is just our like our hypothesis or our really good guess to the final answer. So hopefully you can see how I got that. It's 5x minus 1, 3x plus 2. Now what we're going to do is we're going to multiply everything and make sure we get what we got in the white terms. So if we do 5x times 3x, that is positive 15x squared, so that's good. And then we do 5x times 2, that is 10x. Then we do negative 1 times 3x, and that is negative 3x. And then negative 1 times 2 is negative 2. And so this is our factored form. Okay, let's do the same thing. Now, something that I didn't stress in the other video for the other method, but I'm going to stress right now. When you're factoring, you need to factor out any common factors before you try any of these methods. So we have 20, 46, and 24. Those are all divisible by 2. So the first step I'm going to do is divide everything by 2 and write what I have left over. This does two things. One, it gives you the correct answer, and two, it actually makes your life easier. So we will carry this 2 down throughout, but we're going to kind of forget about it for a second, and then just tack it on at the very end. Okay, so this one needs to be t-factored because there's a number out in front right here. So if I do 10 times 12, I get 120. And 120 has a lot of factors. So 1, 120, 2, and 60, 3, and 40, 4, and 30, 5 and 24. Feel free to use a calculator, by the way, so you can just take 120 divided by 5 and see what it is. 6 and 20. 7 doesn't work. 8 and 15, I think. I want to double check that, so I'll just show you on the calculator. So 120 divided by 8 is 15. Okay, 9 I don't think works. Okay, and then 10 works. And then 11 won't work, and that's the only thing in between there. Okay, that's a lot of stuff. We want to make them add up to negative 23. And so, let's see, that's not going to work. That's not going to work. None of these work. This almost does 22. Then if we make both of these negative, those will add to 23. So we found negative 8 and negative 15. So we draw our box. Then we take our, and remember, I'm only dealing with the stuff inside the parentheses for now. This 2 will show up at the very end. Okay, I take the first piece and the last piece, put them in the top left, bottom right. And then remember, we're splitting this into 2 pieces based on this information. So we get negative 8x and negative 15x. Okay, now we're going to factor out. So on the top row, 10 and 15, we take out a 5. X squared x gives us an x. And when we look here, 4 is the biggest number we can take out. And then 10 and 8 is going to be a 2, and then x, and then 3. Okay, once again, this is like my hypothesis. So if I do 5x times 2x, that gives me a 10x squared, so that's good. Now 5x times 3 would give me a positive 15x. Now, I've already used the 5x with the 2x to give me something that I like, but since this is the first time we use the 3, I'm going to change the sign there. Now 5x times negative 3 equals negative 15x, so that works. Now 4 times 2x, once again, the sign doesn't work, but I've already used the 2x to get me something that I like, so I'm going to change the sign on the 4. And then I test the last one. Negative 4 times negative 3 is positive 12. And so this will give me my final answer. Okay, this is the factored form of the stuff up here, but we still want to use this 2. So we're going to put a 2 out on the outside. And so all of that together would be my factored answer. Okay, let's try this one. So these are all not divisible by the same number. So we do -6 times -5. That's going to be positive 30. And then we already saw that, so I'll just go quick through this. Okay, we want them to add up to -13. So this works, and then 15, let's see, -15 plus 2 would also work. And so this is where we have to test it. -3 times -10 is positive 30. But this times this would be -30, and so that doesn't work. So these are the ones we want. Draw our box. Okay, we take our first term, our last term. We're splitting this into 2 based on this. -3x. -10x, and then we factor out the top. That's going to be -2x, and then we factor out the bottom. That's just -1. Factor out the first column. That looks like -3. Factor out this column. Looks like -5. Over here there's an x as well. Okay. Once again, it's a hypothesis. So if we do 2x times 3x, it's going to be it's going to be positive 6x squared. So we got to change one of those signs. It's hard to say which one off the top of the head, but let's change. Let's see. Let's just try the 2 and see if it works out. So I'm going to change that to a positive, so now that works. Now 2x times -5, that works. -1 times -3x, that doesn't work. But since I used the negative already successfully, I'm going to change this one to a plus sign. And then 1 times -5, that now works. So if I just write my final answer, and that's my factored form. If you need additional help, please come to Math Lab. Until then, calculator.